Hello, colleague. Welcome to my channel. So many people requested, we are launching a new SQL advanced course here. We will cover each and every topic in detail. Support me with a like and subscribe. Don't forget to share this channel to your friends. Your support motivates me to launch many courses. Also, we have many free courses available in our channel. Please visit. Let's go to the video.
Okay, guys, in the previous session, we tried to understand how to install SQL Server Management Studio, and we successfully installed Server Management Studio and SQL Server. Now, in this session, we also discussed types of databases, uh, default databases like system defined databases, and then we have seen four different type of databases available in SQL Server. When we open the system defined databases, master, model, MSDB, and a tempdb. Now in this session we'll try to understand how to create a user defined databases. So first, to creating a user-defined databases, let me open SQL Server Management Studio. I'll go to Start. Then try for SSMS or SQL Server Management Studio and open the SQL Server. Okay. Then click on here Connect button to connect the SQL Server. So we click on here Connect button. Right now, we'll see how to create a database. So in SQL Server, for creating a database, syntax, can I here syntax to create a database. Create database and database name. So syntax for to create a user defined database, syntax is create a database name. Right? Let me create. Let's say I want to create a database. So we need to click on here new query. If you want to write any SQL queries, click on here new query. Let's say I want to create a database. So we'll start with create database name. So for instance, I'm creating database name as can write here hello underscore colleague db. Okay, I'm just creating hello colleague db. So if I execute this query, select the query, select the statement and click on here execute. So it's just going to create a database. Now command completed successfully. Fine. So whether we need to check whether database created or not, we can go to Object Explorer. In this, expand this databases. In databases, now you see it just created hello colleague the database. Right. So this is how we can create a database. Now, so we just created a database. So whenever we create a database in SQL on SQL Server, it will generate two database files. Right. So what will happen whenever we create a database means whenever we create a database on SQL Server, it will generate two database files. Right? One is called primary data file. Second one is log file. Primary data file. Second one log file. Primary data file, log file. So what is primary data file contain? So basically it contain the startup information, startup information of the database and used to store database objects like tables, views, tables and views, and this will saved with an extension .mdf. MDF stands for master data file. This file will saved with an extension .mdf. I think, but it's called as a data file, master data file, right? And second one is log file. So this file contains transaction transaction query information will saved with an extension .ldf. LDF nothing but stands for log data file. So whenever we create any database in on SQL Server, it will generate two files. One is primary data file, second one is data file. Primary data file with an extension of .mdf, it's called as a master data file. Second file is log file, it's extension with .ldf, a log data file, right? So where can we see these two files? We can see these two files under C programs. Say, I can say this PC, go to C drive, C program, and say program files. In this program files, look for SQL Server, Microsoft SQL Server. And in this Microsoft SQL Server, select your SQL Server instance, MySQL Express, then click on your MS SQL, and then you have a data. In data, you see here is it will create your two files, uh, my .mdf and .mdf, right? Let me show you again. SQL Express, MS SQL, data file. Now you see we have hello collect DB and log file. So primary data log file, transaction log file. So we can see this extension in this location. C program file, then SQL Server, SQL Microsoft SQL Server, then your MS SQL 16, SQL Express, MS SQL, then you have a data. So in this location, you will find both primary log file and uh, a primary data file and log file. Right. Next, we'll try to understand. So before we creating a tables and inserting a data, we'll try to understand what are the different type of data types we have in SQL Server. So if you want to insert some text information or number information or date information, so how we can define the data type, or I can say what type of data types we have to use while creating a tables and while inserting a data as well, right? You can say data types in SQL Server, right? So basically a data type is an attribute that specify what type of data enter by user, such as either it is integer, character, decimal, date, time, etc. Right here, a data type is an attribute, that specifies what types of data enter by the user, such as integer, characters, decimal, date, time, etc. right? So we have different type of databases. So data types. Let's say first we have integer data types, decimal data types. I can say money or currency data types, right? Character data types, binary data types, date and time data types, right? So based on our requirement, we can select the data type, right? So we'll see each data type and their length. First, we'll start with integer data types. Integer data type. We have we have type is uh, tiny int. So basically, if I want to store numbers, the range between 0 to 255 numbers, 0 to 255 numbers, the range of this data type, 0 to 255 integers you want to store, then we can use this tiny int, and it takes 1 byte of memory, right? Then we have small int. Small int, let me characterize like this so we can understand easily. So here, data type, range, and stored memory, right? So small int, if you want to store the range between minus 32,000 minus 32,768 to positive 32,768. So it takes 2 bytes. Next 2 bytes, right? Next we have integer data type, which can take a bigger number, minus 2, 147, 483, 3, comma 648. So if you want to store minus 2 billion to 147 million uh, and 483k records to, I mean the number, to positive same number, just it's a positive number, then takes positive and positive 247, 147, 483 and 648 7 number. Okay. And the size for it is 4 bytes. Take 4 bytes, right? Small it. Then we have big int. It takes a bigger number, minus 9 to 30. I'm bigger number if you want to store 220, can say 223, 372, comma 036, comma 854, comma 7775, comma 808 to, I mean the same number till positive. So we just need to say positive 7, right? And it takes 8 bytes, right? So if you want to store a number based on your range, the input number, based on that, we can define a data type. What type of a data type we have to use, right? And then we have decimal data type. In decimal data type, um, whenever you want to store decimal numbers, in that case, we can go for decimal data type. Get it here. These data types will allow only decimal numbers, and it can divide to divide into two types, but both are when I say uh, it takes number, so it's basically decimal, and then we have to provide p comma s. What is p comma s means? P comma s. P stands for precision and D for scale. Precision, and s is equal to scale, basically, right? And we also have a numeric p comma s. So we can also give, either we can use number, decimal, and say your precision and the scale, and the p numeric precision and p comma s we can give, right? So when I say precision, basically it allows the total number of decimal digits, that is both left and right side of decimal points. The default precision is 18 and maximum is 38. So precision is nothing but, so basically it allows the total number of decimal digits, that is both left and right side of the decimal point. The default precision is 18, maximum is 38. So like say example of connect here precision. Let's say if I enter 3457.78543, right? So so what is the precision? Precision is basically, as I mentioned, it takes both a left and a right side of decimal point. So left side we have four numbers and the right side we have five numbers. So the total precision is 9, right? And when we say scale means it allows a right side digits of a decimal point only. So the default value of a scale is 0. Scale is nothing but it allows right side digits of decimal points only. So the default value of scale is 0, right? Let's say example of scale. If I write here 3457.78543, then the scale equal to 5. After decimal point, we have 5 numbers. So here, next we have, like, if I talk about precision and the stored memory, precision stored memory. Let's say if it's a precision of 1 to 9, then it takes 5 bytes. Then 10 to 19, then it takes 9 bytes. If it is 20 to 28, 13 bytes. 29 to 38, 17 bytes. Now, next we have money or currency data type. Coming to money or currency data type, is again here we have two types. One is small money, second one is money. allows currency values, and it contains two. These are, can I here, data type, and then we say range and stored memory. Now here I can say data type is small money. Small money range is minus 214 comma 748 comma 3648 482. Again, positive 214 748, and number is here 7. Right? It takes 4 bytes. Right? Then we have only money data type. It takes a bigger number, 922 922 comma 337 comma 203 comma 685 comma 477 comma 5808. Then here 2 again. So that's a minus. Then we have positive. Here we have 7, and it takes 8 bytes. 8 bytes. Right? So money data type. Next we have date and a time data type. Time data type. So basically these data types are defined a particular data time of day. There is a day data type. It defines date only. The default format of date data type is YYMMDD. Defined a particular date and the time of the day. Let's say we have a date. So if we are inserting only date, then we can use date data type. It defines date only. So the default format of the date data type is year YYMMDD, right? Then we have time data type. So basically it defines time of the day. So the default format is hours, minutes, seconds, dot milliseconds. Right. Next we have date and time. So if you have both combination of date and time, then you can use date time data type. So this will allow both date and the time of the day. Both date and the time of the day. Right. So if you have combination of both date and time, so in this case, it would be like YYYY year, comma, MMDD, and space hour, minutes, seconds, dot milliseconds. Next, we have character data types. Character data types. So in character data types, it will allow to enter character value, and these are classified into a 6 types. classified into 6 types. So the first we have char of n. So when you enter char of n is nothing but char of, you can enter number. So it is a fixed length. It is a fixed length data type. It stores string values in a non-Unicode manner. That is, it will take one character per one byte, right? And the maximum length of character data type from 1 to 8,000 bytes. So basically, it is a fixed length data type. Store the string values in non-Unicode, non-Unicode manner. So say non-Unicode manner, that is, it will take one char per unit, one one byte, right? And the maximum length of char data type is from 1 to 8,000 bytes. So if you want to enter some only a 10 digit value, 10 characters, then we can write here char of 10. So when I write char of 10, it means that I can enter only 10 characters, right? So like that, you can enter maximum 8,000 characters, right? Now, next we have var, varchar, varchar, varchar of n or max. So when you enter varchar, it is nothing but it is a variable length data type. So it will store string values in non-Unicode manner only. That will take one character. That will take one char per one byte. So the maximum length of varchar data type is from 1 to 8,000 bytes. Right. So even so, it is like a it is a variable length, variable length data type, right? And it will store the string values in non-Unicode manner. That is, it will take one char per one byte, right? So again, the maximum length of varchar data type is from 1 to 8,000, right? Next, we have only text data type. Data type is text. So text data type it is the same as varchar max data type. So when you write varchar max data type, so you can enter a maximum length. Next, we have nchar. So we have char and then we have nchar, nchar of n. So it is fixed length data type. It will store string value in a Unicode manner. When I say Unicode manner, it will take one char per 2 bytes. Fixed length data type, store the string values in Unicode manner. That is, it will take one char per 2 bytes. Right? Then we have n varchar max and varchar of n comma max. Again, it is a variable length data type. Store the string values in Unicode manner. Again, same. That is, it will take one char per 2 bytes, right? And here the maximum length of char data type from 1000 to 1 to 4000 bytes, 1 to 4000 bytes. Connect here. Maximum length of char data type is from 1 to 4000 bytes, right? Then we have n text. N text, it is same as n varchar max data type. Same as n varchar max data type, right? So overall we have 6 data types for characters. So char n, varchar n max, text n varchar, uh, n text n char n, right? Now similarly we have binary data type. So when you say binary, it is used to store images, videos, and audio data. Again, further, this can be divided into binary n, var binary n or max, then image data type. Binary data type, binary data type, binary data type are used to store images, videos, and audio data. Right? So this can be divided into connect here following types. So first we have binary n, binary of n. So when you say binary of n, it is a fixed, fixed length data type, and the maximum length of binary data type is 1 to 8000 bytes, right? Then we have var binary of n or max. So we can write here it is a variable length data type. So the maximum length of binary data type is again 1 to 8000 bytes. Then we have image data type. It is same as same as var binary max. So if you want to store any uh, image, video, or audio data, then we can use binary data type. And note here instead of text and image data type are using var max and var binary data type. Instead, uh, in various versions, these small corrections are there. But yeah, this whatever we are discussing, these are like standard. We can go ahead and use, right? So these are all data types that we have in SQL Server. Now, apart from this, we also have other data types. We have a data type called unique identifier. Other data types. Mm, You have unique unique identifier. So it will stores GUI GUIDs. GUIDs means what? Nothing but globally unique identifiers. Identifiers. Then we have XML stores XML data. We have JSON, not a specific type, but stored as n varchar. specific type, but stored as and variable. Then SQL underscore variant. So it will stores values of different data types. Then we have hierarchy ID. So it will stores hierarchical data, hierarchical data. Then we have geometry, or we call it geography. So basically, whenever you have spatial data, some longitude, latitude of type of data, then geographical data, we can use this as geographic data type, right? So these are all data types available in SQL Server. Now, next we'll start trying to understand after these data types, we'll see um, about the structure query language, about the SQL. So SQL, hmm, let me write here, structured query language. SQL stands for like this, structure query language, SQL. Hmm. So SQL. So SQL is a non-procedural language which is used to communicate with any database such as Oracle, SQL Server, or MySQL, any type of databases we can connect with the help of SQL. Non-procedural language which is used to communicate with any database such as Oracle, SQL Server, etc. Right. Now we'll try to understand. So who developed this SQL Server? So this language was developed by German scientist Mr. E.F. Cod in 1968. Right. And this approved by ANSI, American National Standard Institute, and this concept in 1972 SQL was released into the market. So this I can write here, language was developed by German scientist Mr. E.F. Cod in 1968, and ANSI, nothing but American National Standard Institute, approved this concept, and in 1972 SQL was released released into the market, right? So basically SQL is a non-procedural language which is used to communicate with the database such as SQL Server or Oracle. We can use SQL, and this language was developed by German scientist Mr. E.F. Cod in 1968, and this concept was approved and released in 1972. So further in next session, we'll try to understand about the some features of a SQL Server, SQL, some features of a SQL, and then we'll try to understand what are the different type of sub languages we have in SQL. Right? Thank you.
Support me with a like and subscribe. Don't forget to share this channel to your friends. Your support motivates me to launch many courses. Also, we have many free courses available in our channel. Please visit. I hope you like this video. We will see you in the next video.